Today we're going to look at how to calculate molecular formula. And molecular formula, if you want to abbreviate that, you can abbreviate that MF for short. The molecular formula is just a chemical formula with it a whole number of multiples of an empirical formula. And this does apply to molecular compounds. Remember, molecular compounds are when you have two or more nonmetals bonded together. So last class we learned about the empirical formula, and we said that was the simplest formula. And so like for example, CO2 would be an empirical formula. So a molecular formula of that, if you were to just multiply it by 2, if you multiply the subscripts by 2, a molecular formula of that empirical formula, if you said times 2, would be C2O4. Or if you said times 5, it would be C5O10. Oh, that should be a C, sorry. C5O10. So it's just a multiple of the empirical formula. What a molecular formula does is it shows the number and kinds of elements in the molecular compound. So it's going to be a multiple. You do not want to reduce it. It's going to show you the actual number and kinds of elements in the compound. To calculate the molecular formula, you're going to need to know two things. You're going to need to know the empirical formula. So if they don't give you the empirical formula, they would need to give you the percentages of the elements in the compound. And so remember from last class's lesson, we learned a little rhyme. And the rhyme helped us remember the steps to finding an empirical formula. And that was percent to mass, mass to moles, divide by the smallest, and round to the whole. So if they don't give you the empirical formula and instead they give you the percentages, you would need to find the empirical formula. Now once you find that, you would calculate its molar mass. And then they're going to also have to give you the true molar mass of the compound, so of the bigger formula, the molecular formula. They're going to call that either true molar mass or molecular weight. Once you know those two things, you can find the molecular formula. So let's look at an example that sort of piggybacks on the problem we ended the last class with. In the last class, we found the empirical formula of a compound known as diborane. We found its empirical formula was BH3. And here they're telling us that diborane has a molecular weight or a true molar mass of 28 grams per mole. And it wants us to know what is the molecular formula. It wants us to determine the molecular formula. So let me just kind of break it down step by step. If you're asked to find the molecular formula and they give you the empirical formula, the first thing you want to do is calculate its molar mass. So looking at this formula, breaking it down, there's one boron, so 1 times 10.81. So you'd get that from your periodic table. That's the atomic mass of boron. There are 3 hydrogens, so 3 times 1.01 gives you 3.03. So when you add that together, you get a total of 13.84 grams per mole. Now once you have the molar mass of the empirical formula, remember that's the simplest formula, what you're going to do is divide the given molar mass, the given molecular weight, which is here, okay, so that's what I'm talking about there. So 28.00, you're going to divide it by the empirical formula's molar mass. So you're going to divide 13.84 into 28.00 and see how many times it goes and round that to a whole number. So if you divide that, that rounds to 2. That means that the molecular formula is 2 times larger than the empirical formula. So the last thing to do is multiply the subscripts of the empirical formula by your answer. So remember the empirical formula was BH3. So if you multiply the subscripts by the 2 you figured out up here, you just multiply, you get B2H6. This would be your molecular formula, B2H6. All right, so let's take a look at a second example. Here we're told that the empirical formula of a compound that contains phosphorus and oxygen was P2O5. This is the empirical formula. The true molar mass of the compound is 284 grams per mole. What's the molecular formula? So again, we're going to first find the molar mass of the empirical formula. So for phosphorus, there's 2 phosphorus here, so we're going to say 2 times 30.97. And then we're going to say for the oxygen, since there's 5 oxygens, 5 times 16. So let's see what that's going to be. Take a second and calculate that. So the 2 times 30.97 gives us 61.94, and the 5 times 16 gives us 80.00. Now when you add both those together, you end up getting 141.94 for the molar mass. Now remember, this is the empirical formula's molar mass. So that's the simplest formula's molar mass. And so now what we want to do is figure out how many times this number will go into the larger molar mass, because that's what we need to multiply by. So the next thing we're going to do is say 284 divide by 141.94 and see how many times that goes. And that's going to be 2. You round that to the whole number, you get 2. That means the molecular formula is 2 times the P2O5, which is going to give us P4O10. Now, you would not want to reduce that. We are looking for the molecular formula, which is going to be a multiple of the empirical formula. So this will be your answer. In the next lesson, we'll go through and look at 2 more advanced problems, a little more complex problems than this, but these are our 2 examples for our notes today. So the next video lesson, we'll look at 2 examples from a practice worksheet.